All right, so let's finish up by talking about some advanced capabilities, advanced security capabilities that Tetration has. I always get this question from customers, can we take all this data and put it into a dashboard so that we can see all of this in one place? Yeah, it's 2020. Of course, there are dashboards, right? You can make your own, or Tetration ships out of the box with multiple dashboards. In this dashboard, we're showing you the vulnerabilities, hence the title of the slide, Vulnerability Dashboard. But there's more than just this one. Now, what's really cool about this dashboard is that you can either see everything in your environment. So here we're currently listing the default, meaning everything in the environment, or you can actually drill down to individual applications. So you could see just the applications in HR or just finance. Within finance, you might be able to just look at, the billing, the billing app or something like that. So you can see everything, or you can drill down and see a good amount of detail. In this dashboard, we're going to let you know what that vulnerability is. In other words, what is the score? In this case, in this screenshot, it's a 9.8, and it's a critical vulnerability. I think anything from a CVE version 3, I think anything above 9 is considered critical. So we are showing you that this particular application, this particular workload has a critical vulnerability. But we're also going to identify the access complexity, meaning we're going to let you know how hard it is, or how worried you should be, that an attacker could actually exploit that particular vulnerability. So if I have a critical vulnerability, but it's relatively high complexity, that means that an attacker is going to have to run some tools. It's going to take them some time. It doesn't mean I'm not worried, but I'm definitely more worried about a vulnerability that has a low complexity, meaning it's relatively easy and less time for an experienced attacker to be able to get into my environment. We're also going to let you know what the impact of that vulnerability is. So we'll let you know if these vulnerabilities have a serious impact to your environment. Again, all these things are very, very important for you to know. It's not just, hey, I have a vulnerability and it's critical. It's what can these things do to my environment? How much should I worry, right? If I just gave you a list of vulnerabilities, I've really done nothing for you. You need to be able to prioritize. You need to be able to come up with some logical plan to fix the problem. And so we try to help you out here with this dashboard to show you that information. But just like we were talking about with the visibility of Tetration, if all I do is turn the lights on for you, I have done really nothing for you except make your job a lot worse, right? So all this information is relatively useless unless you can dynamically do something with it. And with Tetration, we don't only provide the information to notify you, but we give you the mechanism to actually act. For example, being able to see any system with a CVE that's greater than 9. So show me if any system within my environment, any database, web server, file server, Active Directory server, doesn't matter what it is, show me if any server with a CVE greater than 9 is talking to my crown jewel database server, or the core of my, the core of my company, right? Show me if we have anything that has these critical CVEs that are talking to my organization, right? Or let's create a policy that can restrict access or allow access to an application based on a specific software package. So maybe we're looking for a specific version of OpenSSL because we know that maybe this version of OpenSSL has a specific vulnerability that we're worried about. And so we want to restrict everybody in the world from using it, but, maybe in our organization, we're kind of stuck using it for now. So we want to kind of try to find some middle ground policy where we're not going to let everyone use it, but we're going to let what's essentially critical and needs to function use it. So again, reducing that attack surface, right? Shrinking what an attacker can and cannot do if they were able to actually exploit some vulnerability in your environment. What about restricting access to only Windows operating systems that might be susceptible to something? In this case, WannaCry. Think about how you would do this today. How would you create a dynamic policy across all of your infrastructure that says, if it's a Windows operating system, then I want you to prevent it from accessing maybe the internet, or I want you to prevent access, but only on port 445. right? I want you to make sure that that port is blocked because we want to limit what an attacker may or may not be able to do if they're exploiting this particular vulnerability, but only on Windows, right? Linux, we don't really care. Do whatever you want. How would you do that today? You would need to know the IP addresses of every single Windows system, which in reality is not really that easy to do, right? You'd have to have some giant spreadsheet. You'd have to be exporting your DNS. You'd have to be comparing that to host names, and hopefully you've put the operating system in your host name, like maybe MS or WIN hyphen whatever. But most customers I deal with have no real easy way to identify what the operating system is without having to go through multiple different systems and then combining that through some automated process like Python or Ansible, etc., to kind of find that list and then push out this policy. Tetration can do it literally in the 2 lines that you see here. So essentially what we're doing is we're denying everything to only Windows systems that are susceptible to WannaCry. And we're not even doing it to everything. We're only doing it based on PCI. So in other words, our PCI zone, we're only preventing this traffic to get into the PCI zone because obviously we have to make sure that we're compliant. So there are a lot of things, there are a lot of different ways that Tetration can leverage its ability to identify software processes, to identify software packages like versions of software, as well as actually match that software version against known vulnerabilities that are out there in the world. So there is a great many things, as the Emperor would say, that you can do. But identifying vulnerabilities is only part of the solution to reduce your attack surface and limit your exposure. We want to be able to identify when workloads have known malicious processes. So what we want to be able to do is actually limit what these workloads can talk to if and when we identify malicious processes. And again, we want this to be dynamic, meaning once a malicious process is identified, once either a process is spun up or it's been running the whole time and Tetration is now installed and discovers it, once we see that this malicious process is there, we want Tetration to automate the policy that restricts data access. I mean, you don't want to sit there, none of us want to sit there day in and day out and create these policies that say, okay, we have a new vulnerability, I'm going to go create this policy. Okay, somebody lets you know that the system is patched, you verify it, now you remove the ACL and grant it back access. Nobody has time for that, which is why we don't do it today, right? But imagine if you had a system that could dynamically do that. If I see malicious software, if I see a certain malicious process, if I see something like that, I'm going to go ahead and I'm going to restrict access. Once that vulnerability goes away, or once that process is no longer running, whether that software is removed or the process is turned off, however we want to go about mitigating that risk, right? Regardless how we mitigate it or how we fix it, once Tetration sees that those attributes, that criteria is no longer met, Tetration will then open back up access, right? And again, we want to be able to identify when changes in this workload occur. And that leads me to snapshotting the actual workload behavior. This is where snapshotting that process tree comes in. Not only do we take a snapshot of the server's behavior, but we correlate that with known vulnerabilities. So you can see here where we're actually letting you know that these processes that are currently running on this server are vulnerable to specific things. And so you can go between the snapshot of the server to see the vulnerabilities. You can go into the vulnerability dashboard. We're going to spend quite a few minutes going through this in the lab. I'm just showing you some high-level shots right now. But you'll be able to identify when things are running and vulnerable. Why is that important? Well, because when it comes time for me to mitigate a risk, right? When it comes time for me to say, okay, how are we going to prioritize actually fixing our problem? If I have vulnerable software, but it's not actually running and it's not actually being used, ideally or in theory, that should mean that the ports that an attacker would use to access that software hopefully aren't running, or hopefully they don't have access. Not always, right? I don't want anybody to say, oh, that's not always the case. You're right, it's not always the case, but a lot of times it is. And that may help me to identify, okay, I'm not as worried about this server because that software that's vulnerable we don't actually use. In fact, we can just uninstall it, as I am about maybe another critical server that is using that software like Apache or something like that every single day. It's a web server. I need to fix that first. It's a forward-facing, public-facing web server with Apache struts. I need to fix that right away. So we can kind of identify what software is running and how that software interacts with each other. Why is that important? Well, think about your mitigation plan. I may not be able to patch this piece of software because maybe in my process tree I see that these other processes are dependent on it. Meaning, if I go kill this, I'm going to kill 6 other processes. And if this is a shared web server or a shared database server, I need to know that stuff before I just go start running updates or upgrading servers or upgrading patches or doing code upgrades or anything like that, right? Talking to developers and, they're going to update, .NET framework or something like that. That could have a severe impact to our business. That stuff can bring down a web server. So we need to understand how all these different processes interact with one another so that, again, we can come up with a logical plan to fix it that's not going to break anything. Because let's face it, when we break stuff and the company doesn't make money, that's when we have to update our resumes. And because we have this snapshot, we can identify anomalous behavior with our advanced forensics. In other words, we can trigger different events based on different behavioral changes. So you think about something like a MITRE attack, which is really a framework that an attacker would use to try and exploit specific vulnerabilities or try to gain access or try to essentially hack into a server, right? We are not just identifying malicious processes. We are actually looking at the behavior of that server. So when we see, wait a second, I'm seeing these executables that are currently being spun off by other executables that were never there before, or I'm seeing this evil backdoor.exe which I've never seen before. All of a sudden it's being started and it's being spawned from a .NET framework executable, or it's being spawned by Outlook or Excel or something like that. Tetration can then be our mechanism to not only catch this behavior, but then quarantine it or lock it down or prevent access or do whatever type of policy change we need to do, because we're identifying that something is changing within the behavior of that server. Software is being installed, or it's being turned off, or processes are being started, scripts are being run that we haven't seen before. We can identify on a ginormous list of things, and I'll show you that when we jump into the lab. But again, we can identify on simple things like user logon failure. We can identify when users log in and then escalate their privilege to root. We can identify on secure file access in Linux. We can identify when, again, new software is installed or turned off. So there is a long list of things we do, because segmentation is not just source destination protocol. That's not it, my friends, okay? Segmentation, true segmentation, and actual security in your environment is much more than source destination protocol. If all we needed was a firewall with source destination protocol and IP address, obviously, then nobody would ever get hacked, right? Equifax never would have gotten hacked. If all we needed was IDS, IPS, Equifax never would have gotten hacked. There are so many hacks that go across the country, that go across the world. If all we needed was source destination protocol and a firewall with IDS and IPS, these things wouldn't happen. So it's time to really change the way that we think about securing our infrastructure. It's time to change the way that we think about securing our applications. So I'm going to pause the video, and then we'll go ahead and jump into a lab. I'll actually show you how to access a free G-Cloud lab where you can go through some of this stuff on your own. So let me pause the video. I'll be back in just 1 second. All right, so let's start taking a look at some of the dashboard items within Tetration. This should be the first dashboard that you come to when you actually log into the product. And as I was saying before in the PowerPoint, you can drill down to pretty much anything you want. So you can see the entire MS Lab if you want to. So this is, by the way, a free demo within dCloud that you can use. So I can see the entire environment if I want to, or I can go ahead and I can drill down to specific applications. So maybe I just want to see SharePoint, right? Maybe that's all I'm interested in because that's my core app. And then across the screen here, I'm going to see multiple different, well, I kind of drew right down the middle. Let's try that again. I'm going to see multiple, that's what I get for being left-handed. I'm going to see multiple different scores for these different events. So I'm going to have my vulnerability score, my process hash score, my attack surface score. The attack surface score is actually a pretty cool one. Not that the process hash is not a cool one. I mean, if we see any anomalous processes in our environment, we're going to drop the score. We'll get into the vulnerability score in a little bit because we're going to take a look at that dashboard on its own. But the attack surface score is kind of cool. If you click on this, it actually brings you down to that section where you're going to see your score. Now, Within our SharePoint environment, we have 5 servers, and those 5 servers have their own individual score. If I click on SQL02, which is our database server, what's going to happen is Tetration is actually giving me the used ports versus the unused ports. That's what my attack surface is. It's actually made up of the services that are running, but where we don't actually see any traffic. So in addition to actually segmenting our environment, in addition to actually that policy validation that we went through previously in another video, you can also use the dashboard to pinpoint things that are running on this server that are not actually being used. So in this case, it's telling us that you have 19 unused ports on this workload. So out of the 21 ports that are open, right, 19 of them are unused. 19 of them have software that are running. They're just open doors for an attacker to come in and see. And I can check this little box to say, show me only the unused ports, and then essentially that's all I'm going to see listed here. So I can go in and I can mitigate that very, very easily. So it's kind of a cool dashboard. And I can also select a time. So I can go back to maybe May, and I can see, okay, what was my score in May versus what was it on June 28th versus what is it today? And so it's a really, really cool dashboard to come in and try to figure out, okay, am I compliant or not? You know, how is my environment? Now, speaking of compliance, the other thing I want to point out is the compliance score. So this is where we're going to actually see our security policy that we have invoked, right, that we've told Tetration, hey, I want to go ahead and segment this application or this environment. I'm going to go ahead and push down these security rules down to my endpoints. How many rules are we seeing being hit? In other words, how many escapes do we have? So if our rule says that we should block a packet, but yet for some reason we actually saw that packet get to the other end, we know that for some reason our policy was not adhered to. We know that that traffic escaped. It got past us somehow. Why is that? Out of all the packets that we were told to permit, did we permit the right ones? Out of all the ones we were told to reject, how many did we reject? And if we're rejecting a ton of packets, perhaps that's something that we need to go fix in our environment, because we should really see nothing rejected unless we're trying to be compromised, unless somebody's trying to get in and they shouldn't. We should really go turn off all the things that really shouldn't be hitting the policy. So what I'll do is I'm going to come over here to the left-hand side. I'm going to click Security, and I'm going to go into the Vulnerability section. This is where we have a pretty cool dashboard. Now, right out of the box, right, we're going to see some pretty interesting pieces of information. The first thing that I want to point out is I'm going to go here, that availability impact. This is where Tetration was able to show us what would be the impact of these particular vulnerabilities. And again, I don't have to just look at the entire environment. Perhaps I'm just interested in my SharePoint environment, so I can then go and drill down and I can see different scores based on just SharePoint, right? Now, what also is cool is not only am I going to see the impact to these vulnerabilities, I'm going to be able to come down here and get more information on those vulnerabilities. Each one of these links, by the way, are hyperlinks. So you can come in here and you can click on each one of these and you can see what each one is. There was also a description of each one in a previous slide that I showed up, so you can kind of just scroll back in the video and kind of read through those. But Tetration is going to show us any critical vulnerability. So I'm just going to pick on this one here, 2016-0132. If you actually look, Tetration is saying, look, this is a CVE version 3 and it's a 9.8. That is considered a critical. In CVE version 2, which was the older version, it's a 10 and it's considered high. But I like using version 3, right? So if you think about this, right, think about how this vulnerability would affect your environment, because the access complexity is low and the attack complexity is also low. So if you look over here, we have the attack complexity is low, the access complexity is low. This is a critical or a high vulnerability. So this is something that we may want to actually pay attention to. This is something where, hey, you know what? It's actually a critical vulnerability. It could do some damage to our environment, and it's relatively easy for an attacker to actually gain access and possibly leverage that. So this is important for us to say, okay, where does that CVE live within our environment? Maybe we want to find out exactly what that CVE is. So if I click on this, it's going to bring me to the NIST website where I can go and I can read through the different things that maybe I need to know about that particular vulnerability. So I can go in and I can see that. Simultaneously, what Tetration does is when I select that vulnerability, not only does it bring me to NIST's website, but it also gives me all of the affected workloads and the name of the packages that are susceptible to that vulnerability. So now I know that within my SharePoint environment, I have 5 servers that are essentially susceptible or open to this particular vulnerability. There's another view that I can have. I can click on packages and I can see another view, if you will, on these vulnerabilities. So I can say, all right, maybe I'm looking for what's vulnerable in .NET, right? What does that vulnerability look like? What are the critical, packages that maybe I need to go fix? So I can sort this based on that, and I can see what actual packages are vulnerable. Or I can click on the workloads and I can see each individual workload and see what each one is vulnerable. It really depends on how you're going to mitigate this. I mean, you may not patch the entire system all at once, all in one day. You may not perform the fix on every system all in one day. You may want to go system by system based on who has the worst vulnerabilities. So I can find out all that information from here. So for example, if I click on SQL 02, it will let me know all of the vulnerabilities that SQL 02 has. It will let me know based on packages or CVE. So I can even sort the view from here. So I can say I'm just interested in version 3 and maybe I want to see the packages, or maybe I want to see version 2 and I want to see the CVEs. And so I can sort the view even from within this server to take a look at what is it actually vulnerable and how can I go fix that. I can download this information in JSON and I can go, go repair it. The other thing that I can do is I can select any one of these options to essentially gain more information. So if I say, okay, remotely exploitable, there's 48 vulnerabilities within my SharePoint environment that are exploitable remotely and they're low complexity. So I want to know what those are. So I'm going to click this, and what it's going to do is it's going to sort my view based on only those. So if I look here, I should have 48 vulnerabilities. They're all a high, or most of them are high, and they're some mediums down here, but that access complexity is all low. Why? Because I've selected to see those particular vulnerabilities. Maybe I want to see the availability impact. So maybe I want to see, I want to sort just on those. And so each time I select these, it's just a double click. So if I click here once for access complexity, it will sort. If I click here again, it'll go back to the original view. So I can sort my view of vulnerabilities based on which one of these filters I essentially want to see. And this allows me to go in and start creating policies based on those vulnerabilities. So because this is a read-only cluster, the one that we were on previously, I went and logged into my actual lab cluster, and I want to actually go ahead and look at what we would want to do to create a policy based on a vulnerability. So here I am. I'm going to go into my demo app, so let me find that here. So here's my demo app. I'm going to look for anything that's low complexity for remote exploitability, and if that's even a word. And I'm going to sort this based on the severity of version 3. So here I got a 9.8, and I have low access complexity. What I'm going to do is let's copy this. So we'll say Control C. We'll copy this out. Just make sure that I copy that. Sometimes I get click happy. Okay, so I've copied this particular CVE. Again, I can do this based on a software vulnerability, meaning a software package as well. So if I wanted to, I could go to packages and I could look for a specific package. I think in our case here, the vulnerability that we're looking for, 8597. Is this package right here, but I'm going to do it based on the actual vulnerability. So what I want to do is I'm going to come in and create an inventory filter. Watch how quickly I can do this. So actually, I think I may, do I have one already for CVE? No, I don't. Let me create a filter. What I'm going to do is I'm going to say CVE, okay? And what I'll do down here is if I click on the query and I left click on that question mark, you'll see that I have a number of different options. Now, all of these options down here with a star are ways that I can create inventory filters based on information that I'm adding into Tetration. So in this case, I can use ICE tags, I can use vCenter tags, I can use CMDB data. But all of this stuff here is out of the box. So I can filter based on host name. And what we're after here is we're going to be looking at the package CVE. But again, I don't just need to create a policy there. I can use any of the any of the vulnerability dashboard items that I want to. So for example, I could use the access vector. I could use the access complexity. I could say if the access complexity is low and the CVE is critical, then maybe I want to do that. So let's actually try that, because why not? So let's say, what did I want? Access complexity. So let's say access complexity equals, we'll say low, and I'll say and, whoops, let's go back, and I'm going to say and, we'll say CVE version 3 score is greater than, let's say 9.8, and we'll say next. We don't have anything. Let's do a 9. Let's do 9.5. Let's see if Tetration spits out anything. Okay, there we go. So now what Tetration is doing is, again, building a dynamic filter. I'm saying, you know what, Tetration, anytime you find a vulnerability in my environment that is an access complexity of low and a critical vulnerability, I want to do something with it. In fact, let's do critical CVE. That's what we're going to name it. And we'll say create. So now this does a couple of different things for me. I can either just use this to search and look for anything that matches that criteria. So when I select that critical CVE filter that I looked at, Tetration gives me output of every single server in my environment that's going to match that particular filter. But I want to use it in a policy. So what I'm going to do is I'm going to go to my global InfoSec policies. You folks should have remembered this from another video. And I'm going to go ahead and add this to a policy. Okay, so what I want to do is I'm going to go ahead and deny access to anything that that has that option, right? So now this isn't necessarily the way that I would always build this policy, but I just want to show you guys essentially how I would do this. So I would say maybe let's do critical CVE, and I'm going to say I want to deny it access to the data center. We're going to say okay. And I'm going to say any. So I'll come over here and I'll say how many ports do I want to deny it access to. And there we go. So now, even though my catch-all is deny, the first thing that I'm going to do is actually deny anything that matches this criteria with a access complexity of low and a CVE score of greater than 9.5, I'm going to deny it access to the data center, okay? Or maybe the right way to do this would be only allowing it access to certain resources within the data center. So in reality, because this is a whitelist model, again, I'm just showing you how quickly we can do something like this. So if you were in a tight spot where you were compromised or you did have something critical happening in your environment, I'm just showing you how quickly you could jump on that within Tetration, because the minute I come over here and say enforce, Tetration will then push this rule down. Actually, it's a pull, but you get the idea. This rule would then be sent through all my infrastructure, and my endpoints, my workloads in my data center would then begin blocking traffic based on this CVE. In reality, what I would really do is I would probably edit this rule. I would set this to allow. I would say 100. Whoops. I would set this to allow because it's a whitelist, and then I may only allow it access to, you know, specific things within my data center. Like maybe I would allow it access to maybe my VDI environment, and I would only allow it access to maybe certain things, or maybe this would be shared resources or something like that. I would allow it to maybe utilize DNS or something like that. So let's do shared services, maybe just IPAM. You know, I'm making this up, right? But that's really how I would do this, because since the catch-all is deny within Tetration, I would only allow these critical CVEs to see whatever they would need to do their job. I certainly wouldn't allow them access to P2, certainly wouldn't allow them access to production or things like that. So this is a really cool, easy way that I can dynamically create this policy. So now what will happen is, as Tetration sees these things in my environment, Tetration will dynamically add to these policies or dynamically take away to these policies based on what Tetration actually sees, based on my filter. Again, I'm not saying this is exactly what I would do in production. I'm not saying this is exactly how I would build this rule in production. I'm just showing you what's capable from the vulnerability rules that you actually, or information that you actually find within your environment. So it is a really, really great way to protect yourself. Now, what I'm going to do is I'm going to jump back to my dCloud cluster, and I want to look at forensic analysis here for a minute. So I'm going to go to security. That's where my dashboards are found. And I'm going to look at forensic analysis. Now, I'm going to go and show you I'm just going to show you some of the events and kind of how we capture this. I'm not going to jump into any specific event. I don't think that this lab has been hacked ever, so we're not really seeing anything that's crazy or anything that stands out. So I'll finish up this video in with a PowerPoint that actually walks through a story where we were hacked in a separate environment. But for here, I just want to show you guys what we're actually capturing. So I'm going to come over here to filters, and I'm just going to click this question mark. I'm going to sit here for a second and allow you to read the events that we can trigger. So if I see the LDAP username equals, JP Cedino, and the event is him kicking off a specific command and he's using PowerShell to do that, right? If I see that event, or I see anybody where maybe the LDAP department is IAT and they're escalating their privilege to root, or maybe the reverse, right? Trigger an event if the LDAP department is not IT and you see an SSH connection, right? Simple things like that are things we can do, right? Hopefully you've read through this list. I'm going to scroll down here. Binary changes, binary attribute changes. I mean, the list here is obnoxious. I'm going to just let you read here for a second. Unseen commands, different MITRE behaviors. Again, as I was talking about MITRE attacks, we can look at different privilege escalations. We can look at different source ports that users use to log in. We can look at shellcode execution. Again, file access for secure files. So if we see any permission changes to read-only files, or like a password file in Linux, for example. Again, if we see any binary changes, or if we see file access to, if a command line to specific files. I mean, the list just goes on and on and on of the different behaviors that we can actually alert on. And all these different rules are configurable. So what I mean by that is you can create custom alerts based on your environment. We do have a lot of out-of-the-box rules, which I'll show you in a second in my other lab, but all of these things are configurable. You can ask Tetration to look for specific events. You can search for specific events. You can create your own rules based on a combination of these events. And you can create alarms, you can create automation, you can really do whatever you want as any of these behavior filters are identified. I'm just going to click one of these just for fun. I don't think this is anything malicious. In fact, I just think these were just simple commands being run by some automated processes that we have. In fact, you can see here that it was actually the Tetration sensor that was doing some of these things. But what's interesting is that, you can come in here and you can say, okay, well, I'm seeing these command line things run. I'm seeing these unseen commands. And I'll actually just say, hey, look, show me unseen commands. Let's say unseen command. So here you can see that this drop-down list actually comes down. So we'll say if the event type equals unseen command. And again, remember that Tetration is a big data cluster. It remembers these things for up to a year. Imagine a system where somebody comes to you and says, hey, Joe or Cindy or whoever left 3 months ago, and we just found out that they were disgruntled when they left, and we're pretty sure that they stole confidential data. Can you go and search through Tetration, or is there something you can do to search everything that they may have had access to? Maybe they were an IT admin. Can you see every server that they logged into 3 months ago and show us what they may have done? And you can say, yeah, sure, no problem. Let me go into Tetration. Let me pick the time frame that we're looking for. So let me go back 6 months, or let me go back to that 3-month mark, and let me look at any type of unseen command where, that LDAP username equaled or contained, JP Cedino or something like that. Nothing's going to come up, obviously, but you see my point, right? Like, I can search for this within Tetration, or I can create automated triggers to say, you know what, Tetration, anytime you see an unseen command, and that unseen command was because somebody used PowerShell and SSH'd into a server, or they used PuTTY and SSH'd into a server. I mean, you can get really, really creative to see some of these things. And so here's just a simple event where, Tetration is saying, hey, look, I'm seeing that there are some commands that are being run that I haven't seen before, and I'm going to go ahead and just log them here for you to come in and look at. I don't think that they're malicious, but I'm going to log them here for you to come in and look at. So I can sort these based on unseen commands. Now I'm going to jump to my other cluster where I actually, keep in mind that cluster was a read-only cluster. So what you're missing is the ability to configure your different alerts. Here's where you can configure various different alerts, and a lot of these, in fact all of these, are out of the box. So These are pre-configured rules where tetration is actually looking for specific types of behavior on our server. And now in this case, again, it's a MITRE attack. It's looking for different account creations. It's looking for maybe screensaver files that are being run. You can see here a predefined rule that alerts and records if a process is created with an SCR. So again, if somebody tries to use a screensaver file to access or kick off any type of malicious processes on our Windows servers, these are things that tetration is going to alert on. Specific suspicious activity in Microsoft Office, right? So these are things that tetration is going to automatically alert on and record, or again, we can build our own. So if tetration sees privilege escalation, or if it sees an unseen command or a raw socket creation, when these behaviors change in our servers, tetration is going to know about it. So let me pivot over to a presentation where I actually walk through us actually getting attacked. So a while back, one of our TSAs actually had a honeypot server running in AWS, and of course this server was running Apache struts, and we were running it on purpose with a tetration agent because we wanted to see if tetration would really capture these events in real time, and if it would essentially identify when these behaviors or when these things were taking place. And sure enough, that's exactly what tetration did. So the attacker essentially exploits Apache struts, gains access to our server via SSH, and I hope you guys can see the screenshot. And then down here, you can actually see that the attacker is able to escalate their privilege to root and actually does a wget and downloads this package called minitools from this IP address here, 39.104.163.13, which we found out later was coming from within China. Now, what was interesting is that tetration also does geolocation out of the box. I'll do a small video on that perhaps later on. Does geolocation out of the box. So tetration was also able to help us identify exactly where this traffic was coming from. Now, the next thing that the attacker does is the change mod on the on this minitools package that they downloaded, and they essentially make it an executable. All right, so now they go and they actually exploit Apache struts. They've downloaded this package called minitools, which was a zero-day attack. Nobody knew what it was. Okay, the attacker runs minitools by executing it against the shell, and then this minitools process becomes its own new spawned process. Okay, which is really interesting because when minitools actually began to launch, it spawned all of these new child processes, and you could see this here. So this is a perfect example of, and this is a real-life example, a perfect example of how tetration is seeing the behavioral changes within a server. It's seeing that all of these new processes are being spawned, and they're being spawned by this unidentified process called minitools that was recently downloaded, and tetration is playing this entire picture out for us. Here, this blue is the attacker actually logging in through Apache struts. Here is the user identifying or escalating its privilege and doing the wget, downloading minitools, running minitools, and so we're actually able to see all this information. But it goes way beyond seeing just, or it goes way beyond just identifying that we have this running on a server. We don't know what else this attacker may have had access to. We don't know what other server this particular attacker has attacked. And so what we're going to do is we're going to ask tetration to show us every single endpoint or every single resource in our data center that is running this process called minitools within the last, let's say, 24 hours or even a week, right? Show us if this process exists anywhere in our environment, and tetration can spit out that data. You know, luckily there was nothing else that this attacker could get to. It was just that one honeypot server. But the point is that if you are attacked, if all of a sudden tetration does identify something, you can quickly get in there and you can quickly start saying, okay, I'm going to lock down my environment, but at the same time, I'm going to search my environment out for that specific process. And you can create the policies around that as well. So you can see how these behavioral analytics can really change the way that you respond to an attack, that you respond to behavioral changes within your environment. So I hope you guys enjoyed this little mini series. This is not the last video that I'm going to do on tetration, but it is the last of this little 4 to 5 set series that I'm going to do. In the rest of the videos, they probably won't be as structured or as stepped. They'll probably just be on little one-off features. But anyway, hope you guys enjoyed this little series, and I'll talk to you guys later.